Good morning, everybody. Welcome to Apex Security, Object and Field Security Made Easy. I'm Chris Peterson, Director of Product Management for Apex, and with me is Ted Freeman, a lead software engineer on the Apex team. So first, everybody's favorite slide, the forward-looking statement. As always, make all purchasing decisions based off generally available features. See our website for the full statement. We are a publicly traded company. You know the deal. So let's talk about where we are today with field-level security and object-level security in Apex. Pretty much everybody here has hopefully seen a query like this in our documentation or a demo somewhere. Great, nice and simple. You don't have to build your own ORM. It just works. That's until you start to do something like AppExchange security review. And then it turns into something that looks a lot more like this. That's a lot of boilerplate code, and I spent the better part of a decade writing this myself. So when I took this job, I decided, let's change it up a little bit and do something new. So we added something for you to make it so you don't have to do that boilerplate code, at least on queries where you want to do an all or nothing operation. So the with security enforced clause you see tacked onto the end makes it so that all field and object level security that's referenced in the select or from clause, this doesn't include the where clause, so you can filter on things that aren't visible, will be enforced, and the query will throw an exception if there are any violations in that. Awesome. Get rid of all that boilerplate code. Dead simple. Well, that was a short presentation. No. So why are we here if we already have something that's coming out? Well, this doesn't gracefully degrade, meaning it's an all or nothing operation that actually doesn't tell you what you don't have access to for the sake of not leaking information about your security. This really doesn't work for DML. It only works for queries. And with the rise of Lightning, where you're getting SObjects from JavaScript sources, this doesn't do you all that much good because it doesn't give you a way to sanitize those types of incoming untrusted deserialized objects. I'll also call out that it's currently in a beta state with a GA planned, emphasis on planned, for winter 20. And until it's GA, the AppExchange security review process does not officially bless it as a field and object level security solution. So heads up on that. So let's talk about the meat of what we're here for today. Ted, what did you build us?
Yes, well, thank you, Chris. So in order to address all of the issues that Chris just described, we've developed a new feature that we're very excited to introduce to you today. It's a new Apex method called stripInaccessible. It lives in the security namespace, and it's available now in the summer 19 release as an open pilot. By open, that means anybody can use it, and by the end of this talk, you will all know how to use it. It's actually simple. And it's only available in non-production orgs. So it's available, that's why we're calling it a pilot. It's available in Scratch orgs, developer orgs, and sandboxes for this release. Here is the method signature. As I said, it lives in the security namespace. It returns a new object type, which is just a container object I'll describe on the next slide, called SObjectAccessDecision. The first argument is an access check type, and it comes from this enum, new enum in the code, which has three possible values. And they determine whether it's readable, creatable, or updatable, determines which of the familiar described field result methods are used to check each field of the objects.
And if you're familiar with the old style that I showed a couple slides ago, you'll notice these map one-to-one with the accessor methods that are on SObject describes and field result describes. So use the exact same logic, just pick the enum instead of calling the right method. You'll also notice there's no deletable. And that's because there is no field level security on delete. So for that, we figured you can still just check the object accessibility in a one-liner and make your delete statements secure because they don't have to worry about field level security like these three types do.
Yes. The second argument here is a list of SObjects called source records, which is just the list of SObjects that you want to sanitize or that you want to remove fields from. This actual argument is not modified in any way. The method actually creates a new list of SObjects. The third argument is an optional enforce root object CRUD argument. Normally this is true. It just means that we do the access level check at the object level. If for some reason you're debugging and you want to turn that off, you could use that argument. That's the only purpose that serves. So this SObjectAccessDecision object it's just a container object for the results of the stripInaccessible call, and it has 3 methods. The first method is just to get the stripped objects. So get records will return to you a new list of SObjects which are identical in every way to the input source records, except that fields that did not pass the access check are not included. So they have the same, they come out in the same order, they have the same IDs, they are the same types. The next 2 methods are helper methods to help you understand what happened in the call. The first is get modified indexes. It returns a set of indexes that are the indexes of the SObjects which required a field to be removed. And the third is a get removed fields. This is a map that maps the type of object to a set of, and they're all strings, a set of strings telling you which fields were removed. So those 2 give you a very quick way to check and see what actually happened in the call.
And there's a neat trick with get modified indexes. So if you do want to use this method as an all or nothing check, you want to throw an exception if somebody tried to break field level security, you can use this even though it normally is designed to gracefully degrade, and just check if the modified indexes set is empty. If so, it means there were no field and object level access violations in your input. So if you want to use this as an all or none, you absolutely can. If you want to system.debug those values so that you can tell what access checks failed and on what records, you also can. So let's run through some use cases. Removing fields prior to DML, removing fields for presentation use cases, removing fields in a heterogeneous list, and a live demo of stopping an injection attack in a Lightning Web Component.
So in this first example, we start with a user. We suppose we have a user who does not have field level access to the annual revenue field on an account object. And let's say we have a list of accounts, in this case just 2 SObjects, one of which has an annual revenue set, one of which does not. We call the stripInaccessible method on this list, and we're giving it an access type of creatable for this particular example, and we pass in our accounts. Now to see what we got back, well, first we can go ahead and use the method with confidence to call getRecords, which gives us back this set of SObjects that does not have the fields that we want to remove, and we can go ahead and do a safe insert into the database with confidence, knowing that no fields, in this case annual revenue, will actually be inserted with this DML call. We can look and see what happens in a method like this with simple system.debug statements. We'll just loop over those records and look at each one, and we'll look at the modified records and the removed fields. So if you open the execution log and look at the details column, you will see data that include these kinds of statements. I've stripped off the time and so on, but you see inserted accounts, and you'll see that the accounts only have a name. They have an ID, but they do not have the annual revenue. That was removed. The modified records, index 0, that was, if you'll remember, just the first record had an annual revenue field on it, so it is the one that was modified. And what was removed from account objects, annual revenue was removed.
Great. So let's take a look at another example. Here's a sample starting point of 2 tables. Let's say that we're going to build a UI that shows expense reports that were submitted, but we have 2 use cases. One for HR, who's going to use it for, say, tax purposes, and one for managers who just need to see people's expense reports. So here's our sample tables, some data on them. You'll notice that users have a custom social security field for the sake of having some HR-sensitive data for this example. So let's say we have a query like this that includes the user's social security number, but we're doing a stripInaccessible check on it for readability. This would mean that somebody like a user's manager viewing their expense reports would have the social security number stripped out, and those SObjects would act like that was never set. So not just nulling the value, but the SObject has the notion of the field never being set so that DML operations don't carry it forward. That's exactly what would happen here with that social security field. So we do the same type of thing, debug our expense report objects and the related user object, and then debug our modified indexes and remove fields. And here we go. A little bit more data, but you'll notice in our case, every user had a social security number, and in the manager use case, it was stripped from everybody. So you can use this to do something that Salesforce UIs do normally. If you look at reports, list views, detail pages, all of those gracefully degrade. If you don't have access to a field that's on there, it strips it out and keeps going. It doesn't stop you completely. So we looked at that and went, if that's good enough for us, if we want graceful degradation, we should build something that allows our partners and our customers to build the same type of graceful degradation functionality. So that's the design spirit behind this method, is to let you do that.
Okay, in our third example, we want to emphasize a feature of this method is that you can actually process different types of SObjects together if you so need to. So in this case, let's say we form a list and it contains an account, it contains an opportunity, and in this case, let's suppose we have a custom field set on the account object called flag1, and the running user does not have field level security access to that field. We go ahead and call stripInaccessible again, as we showed before, this time with the updatable access check type. And now instead of showing system.debug statements, let's just look at how we might verify this code within Apex itself. So we can loop over the get records output, and we can use the fairly recently introduced, I think maybe coming up on 1 year birthday for the switch statement in Apex. We can switch on the stripped record. Yes, thank you. We switch on the account on the object type, and we treat accounts and opportunities with separate blocks of code. Within the account, we can also use another recently introduced Apex feature, the isSet method. So in here, all I'm doing actually in this case is just asserting that name is set on accounts, and so we get a true back from calling isSet. And we're asserting that the flag1 custom field, when we check whether it's set, returns false. So it's not set at all. But now you can imagine many other things that you could do with this. So for example, with flag1, the reason I chose a custom field here is that you could set this up. You could set up as many flags as you want that the user wouldn't even know about or care about. But you could use field level security to control which users have that set and which don't. And then you could imagine all kinds of business logic that would follow from whether or not that field is set without having to use a standard field.
In that spirit of graceful degradation, if you're missing financial fields, you can skip your financial services segment of your UI. So this tells you a very key difference that's been very painful to obtain historically of, is this field set at all on the SObject? Not is it null, but is it actually set? And this works on all SObjects, not just the results of this method. So do keep that in mind when you're doing detection of what fields exist.
Right. And just to wrap it up, the opportunity object was a very simple case in this case. It had a name field set, and that was it. So.
Great. And with that, we'll dive over to our LWC demo. Except I seem to have angered the demo gods, and my Scratch org is not letting me log in. So instead, I'm going to go through the code, and I will post a video of me doing the demo once I fix it this afternoon to the sessions chatter page. Sorry about that. So what I've done here is created a Lightning Web Component with an Apex controller that mimics everybody's good old friend, Quick Create, everybody's favorite. So what we have here is an Apex controller that looks fairly secure. It's checking if the opportunity field type is creatable. It's checking the name and amount field is creatable. It's also doing the close date field. So this looks like it's checking every field that shows up on our UI. So we have 3 fields here, and we're privately setting the stage name behind the scenes. So this looks great. Except in my controller, if I do something like set a debugger here, or go through a bunch of minified JavaScript and set a breakpoint in my browser's dev console, I can do something interesting, which is inject values into this opportunity. Because fundamentally, Lightning Web Components or client-side controllers and even JavaScript promoting don't validate that the SObjects you're sending to the Apex controller only have the fields that you would expect on them. So I could add a new field called manager approved through the JavaScript debugger as a user who doesn't have access to that field, set that to true on this payload as it's going up to the Apex controller, and suddenly these checks would no longer be sufficient because I only checked on the fields that I expected based off my UI programming, not other fields that could have been injected. So the demo would have showed you this actually happening, me saving an opportunity as a user who doesn't have access with that manager approved field. And then we do something wonderful. Uncomment this line to make it so that we are doing stripInaccessible for creatable on the opportunity as it comes in, and it would silently remove all of those injected fields. Because we're checking for the fields we expect, we don't really care. If somebody's trying to inject, we don't need a special error message for that. Let's just ignore them. We do give a nice error message to everybody who isn't doing something malicious. And the key difference is just this one line. So instead of having to build cross-object relationship checks, instead of having to enumerate every single custom field on the object at runtime and do checks on those, stripInaccessible is smart enough to only check the fields that were actually set on the SObject, saves you a bunch of performance, a bunch of boilerplate code, and hopefully makes your lives a whole lot easier. So I will do the live demo and put it on the session page this afternoon. Sorry about that. I should not have taunted the demo gods. With that, I do want to point out the reason this is open pilot is because we want your feedback. This being something that people have been asking for a generic solution for years, there's probably a use case we missed somewhere. There's probably a tweak that somebody in the community could propose to make this better. So with that, we've set up a Trailblazer community group. There's a short link there. Or you can just tweet your feedback at me directly. I am CA_Peterson on Twitter. So this is going to be a short pilot. It's an open pilot, but we've fixed all the bugs we know about. And if nobody tells us something convincing to make it so that we improve this, it's probably going to go beta in winter, and then probably GA in the next release. So get us your feedback quick, because once it goes beta, we can't make breaking changes to the API. So call to action, go home, play with this, send us your feedback. If you like it, great, let us know. If there's room for improvement, also let us know. And with that, any questions? Oh, I made a typo when I built the URL, so good catch. Yes. Okay. It's also a group on a Trailblazer community called stripInaccessible Feedback, so you can find it very quickly if you search on the success community. Yes? Yes, so good question. Are there plans to ever allow... So the question, to repeat back because we don't have audience mics, is are there plans to allow you to actually remove a field from an SObject instance once it's been set? It's something we've discussed. There isn't a concrete roadmap around it, but at the moment I don't see a reason why not. So once we GA this, that's probably something that'll come up as the next type of utility method we tackle on SObject. Don't see a reason not to allow that. Would be useful. And for the second part of your question, you said populated fields as map.
Like there is a get populated fields as map, but there's not a get set fields as map. So if I, for example, create a dynamic SOQL query and some of the fields come back null, the code that processes it can't tell the difference between fields that were set as null and retrieve and never set at all.
So get populated fields as map shouldn't contain a key.
That's right. If you retrieve the field and it's null, there's no key. I'm saying, will we ever get a method that allows us to get a key with a null value if we retrieve the field and it's null?
If you have a repro of that, that sounds like a bug, so let me give you a business card.
Oh, no, that I believe that's working as intended.
We will follow up.
Okay, cool. I'll contact you guys about it?
Yeah.
Okay.
Yeah, please do. That is something we can do probably pretty quickly. Yeah.
Okay.
Thank you.
And then we have time for two more questions, maybe? Go ahead.
Who's next? So I have a question, like, what would be the performance impact if we use this method for, let's say I'm, creating or updating a batch of 100,000 records or something, and like, recently I worked on a project with the security vulnerability I had to fix because the check marks are PMD, throws an error. So,
Yes.
So my question is like, will that affect the performance if we update?
Yes, so there definitely is a performance impact to enumerating over all the SObject fields, but we have tested it on over 1,000 SObjects in the same context. We are going to be looking at if there's any way we can get extra performance out of it, and it is more performant than you doing it yourself because the full implementation is in Java code that doesn't have some of the reflection overhead that actually invoking Apex does, and we're using a little bit more lower level APIs in this. So it is more performant than anything you could build to do it yourself, but there is a performance cost, you are correct.
Okay, thank you.
Yeah, the question is it possible to get the original value of the field which was removed during the DML?
You would do that by taking the original SObject list because we don't mutate the input. You'd say, okay, modified index is 0, let me get array index 0 on the input and look at what fields were removed from at least one SObject. So we don't, for the sake of not hampering performance, we don't take a copy of all fields that were removed on all objects. We only give you those two aggregates of what records were modified and what field was removed from at least one SObject. But with that, we hope that you can figure out the answer by comparing your source and output. There would have been a heavier performance cost if we had tried to keep that full detail, and we wanted to make it so that we kept that to a minimum so that it scaled. And we're at time, but Ted and I will be around for questions back over there if anybody wants to ask us any more in person.